Today I'm going to talk about how we built an API for real-time transit data, which we did together with the city of Münster, or more particular, the Stadtwerke Münster GmbH, which is basically a company which does all the public transit in Münster, planning all the routes, providing all the buses, and so on. They do have an internal software which is called the IVU system, which is a management tool used to basically plan all the bus routes, timetables, and so on. And it even provides real-time information about all the vehicles, all the buses, and so on. But we found out that it is only available within a VPN, so in an intranet, in a local system. And we tried to make a publicly available API to basically provide all the available users, like the public domain and also other companies with real-time data from Münster. In addition to that, the format they use is quite complex because it is for specific software. So we tried to create a more open API, which is more usable. And what we did is we created a RESTful endpoint, which basically provides all the static information like bus stops, all the bus routes, and so on, which is available as a simple GeoJSON format. But we also introduced a new Websocket endpoint, which basically provides real-time push notifications to update real-time vehicle positions that can be used in a map or in any kind of dashboard, for example. The API is publicly available, as you can see down on the URL below. And I'm now going to talk a little bit about what we actually did. So in order to make it an easy-to-use API, we basically use the OpenAPI specification, which is a de facto standard, more or less. And therefore, all the APIs that use the standard or the specification are more or less can more or less be used the same way, and which makes it quite easy for other people to use. And in addition to that, you quite easily get an interactive documentation that can help you to understand what this API actually does. In order to make this API scalable, we figured out that the best way to do that would be to separate the data processing and the data delivery. So we have a periodic FME server job in the background running that basically gathers all the data every few seconds, does a little bit of format conversion, reformatting, and all of that stuff, and basically pushes everything to our AWS database. On the AWS side, we have a bunch of services that basically allow us quite easily to connect to all the users and scale. So our architecture kind of looks like this. We have the IVU system on the left. We have our FME cloud virtual machine, which basically does all the data processing. And then we have two outputs. One of them is the AWS services I mentioned. So we are using a Dynamo DB database to store all the data. We are using API gateway to do all the routing and connections to the client, which can be used both for the WebSocket endpoint, but also for the RESTful endpoint. And Amazon Lambda is basically doing all the heavy lifting between Dynamo DB and the API gateway. In addition to that, we also push all of our data to the Google GTFS real-time feed, which basically makes all these real-time bus information available in Google Maps, and therefore it's directly used in all the navigation that can be done there. As I mentioned, our API is publicly available and can be used by anyone. And there's also already a demo application that has been built, which is called Netzplan Münster. And they already use our data, or not our data, but our API to display the real-time bus positions on the map. And as I mentioned, Google Maps also shows the real-time information if you try to navigate within Münster based on the data we are processing. So that's it for my time. If you have any questions, feel free to ask me in the chat or by email afterwards, or try out our API if you want to. And yeah, I guess my time's up. So thank you for listening.